Okay, so absolute value equations and inequalities. Absolute value is the distance from 0 on a number line. Absolute value is always positive because distance is always positive. And extraneous solutions. Extraneous solution is a derived solution that is not actually a solution to the original problem. So you do the algebra just fine. You do everything you're supposed to do to solve the problem. You follow all the perfect steps to solve the problem. And you get x equals some number and x equals some number. But you take those numbers and you put them back in the original problem, they may or may not work. If they don't work, it's an extraneous solution, and you just toss it out. It's no good. Because in order for it to be a solution, it has to work in the original problem. You get those in absolute value problems sometime. You get those, we will get those more often in square root problems, which we do in second semester, and you get those in rational expressions, where you have a variable in the denominator, you're not allowed to 0. Often you will get a solution that will give you 0 in the denominator. Well, that doesn't count. You have to toss it out. It doesn't work. Okay. You do get them from time to time in absolute values. Okay. Now, when you're doing absolute value problems, there's something you need to kind of keep in mind as we start this out. So if I have the absolute value of 2, what is that? 2. If I have the absolute value of -2, it's 2. So if I have the absolute value of something equaling 2, what is that something? 2 or -2. This is the key to setting the problem up. Whatever's inside here, whatever's inside the absolute value, it is equal to 2 or equal to -2. There are 2 possibilities for what's inside the absolute value, equal to the object and equal to the opposite of that object. That is the key to doing absolute value problems. Okay. So when you're solving an absolute value problem, when you have the absolute value by itself, what you need to do is set up whatever's inside, in this case, 3x plus 2. You need to set it equal to whatever's outside, in this case 4, and the opposite of that, in this case -4. Because whatever's inside here, whatever this is inside the absolute value, it's either 4 or -4. Because the absolute value of 4 will give me 4, the absolute value of -4 will give me 4. And you solve those 2 problems to get your possible answer. Subtract 2. 3x equals 2, divide by 3, x equals 2/3, subtract 2, 3x equals -6, divide by 3, x equals -2. Those are my 2 possible answers. I do need to check them. Take 2/3, put it in here for x. 2/3 times 3 is 2. 2 plus 2 is 4. Absolute value of 4 is 4. That's good. -2 in there. -2 times 3 is -6. Plus 2 is -4. Absolute value of -4 is 4. We're good. Okay. So you will always work out 2 problems with absolute values with technically with 2 exceptions. One of the exceptions is if it's equal to 0. Because the only thing that will give me an absolute value equal to 0 is 0. And there's no plus 0 and minus 0, it's just 0. The other one is if its absolute value equals a negative, which means there's no solution because the absolute value number will never be negative. Okay. Second problem. Okay. And I'm actually going to do a little moving around here, so bear with me a moment, folks. I'm going to take the third one and move it down here to give me room, and I'm going to slide this puppy over here to work on that. Okay. So the next one, I actually can't split it into 2 problems. First, I need to solve for the absolute value before I split it. It has to be absolute value equals something before you split. So my first step on that one is to subtract 3 from both sides. That's actually my first step. Subtract 3, and I get 2 times the absolute value of y plus 9 is equal to 4. Divide both sides by 2. Absolute value of y plus 9 is equal to 2. Solve for absolute value. Now I split it into 2 problems. Y plus 9 equals 2. Y plus 9 equals negative 2. Subtract 9. Y equals negative 7. Y equals negative 11. Once again, because there's a possibility of extraneous solutions, I check those answers in the original problem. It has to be the original problem. Put negative 7 in. Negative 7 plus 9 is 2. That's 2. 2 times 2 is 4. Plus 3 is 7. Put negative 11 in there. Negative 11 plus 9 is negative 2. Absolute value of negative 2 is 2. 2 times 2 is 4. Plus 3 is 7. Both went up. Okay, they're both good. Are you with me so far? I do have to split them both. Don't be messing with me now. Okay. This one, slightly more difficult. You have to be a little more careful. Because I have absolute value and I have something other than just a number. Okay. So I do still split it into 2 problems. Okay. Give myself a little more room because I have it here. So I have c minus 3 and c minus 3. And c minus 3 is equal to what the absolute value is equal to. 3c plus 5. And equal to the opposite of that. Negative 3c plus 5. This is where you need to be careful because it's not equal to negative 3 plus 5. It's equal to negative 3 plus 5 in parentheses. The most common mistake students make when they do this is they only change part of what it's equal to. Yes? Yeah, so my first step on solving that one would be to distribute the negative. From here, it's solving the equation. The hard part, the place where most students screw up, is the separation on this one. And then solve, subtract c. Negative 3 equals 2c plus 5. Subtract 5. Negative 8 equals 2c. Divide by 2. And I get c equals negative 4. Distribute the negatives, so c minus 3 equals negative 3c minus 5, not plus, minus. Minus 5. Add 3c. 4c minus 3 equals 5. Add 3. 4c equals 2. Actually, negative 2. That's negative 5 there. Divide by 4. So I get c equals negative 1/2. I have two solutions, and I need to check them into the original problem. So if I put negative 4 in here, negative 4 minus 3 is negative 7. Absolute value of negative 7 is 7. So I have 7 on this side. Negative 4 times 3 is negative 12. Negative 12 plus 5 is negative 7. Is 7 equal to negative 7? It's not that hard a question. Is 7 equal to negative 7? No. That one doesn't work. That's an extraneous solution. Now, which means if I were a betting man, I'd bet that the other one would work. But no guarantees. That's why I don't bet. Like the negative 1/2 thing. Negative 1/2 minus 3 is negative 3.5. Absolute value, that's 3.5. Negative 1/2 times 3 is negative 1.5. Negative 1.5 plus 5 is 3.5. 3.5 is equal to 3.5. This one's good. This one's not good. Okay. 90% of the time when you have an extraneous solution with absolute value, is when you have a variable inside and outside the absolute value both. If you only have them in one place, you generally don't have an issue. But when you have one in and one out, that's 90% of the time you're going to have an extraneous solution. Okay? Your turn. Solve that one. Okay, let's do this one. First thing I need to do is I need to solve for the absolute value. So I add 1 to each side. 3 times absolute value of m plus 2 is equal to 9. Divide by 3. Absolute value of m plus 2 is equal to 3. And I split that into 2. M plus 2 equals 3. M plus 2 equals negative 3. Subtract 2. M equals 1. Subtract 2. M equals negative 5. And you do want to check it. 1 plus 2 is 3. 3 absolute value, that's 3. 3 times 3 is 9. Minus 1 is 8. Negative 5 plus 2 is negative 3. Absolute value, that's 3. 3 times 3 is 9. Minus 1 is 8. They're both good. Okay. Questions so far? Okay, now we're going to get it cranked up a little bit. Oh, question? Question? Oh, okay. So far, Chapter 1 has not been terribly taxing, I hope. I'm going to tell you right now, this section is the one that everybody screws up on the test. I cannot emphasize enough that you do some of the book work to go with this section. You practice these problems. What we are doing here today in the notes is not going to be enough. I cannot stress enough that you need to work more of these problems than we are together in class to prepare yourself for the test. This is the one that everybody screws up. This is the part where everything goes south. There might be minor mistakes here and there, and I would suggest studying the whole chapter we've done, but this is the one that really screws everybody up more than anything else. This is the part I cannot suggest enough you do some of the work in there and practice some of these problems. Particularly the inequalities, because this is where things get a little odd. Still the same process. We still split it into 2 problems. So I have 5v plus 10 greater than 15. But I also have 5v plus 10 less than negative 15. I need to, when I change the sign, I change the inequality. Go from positive to a negative, I flip the inequality, just like solving inequalities. I have to flip the inequality around when I do that. Okay. Then I solve each one. Minus 10, minus 10. 5v is greater than 5. Divide by 5. V is greater than 1. Minus 10, minus 10. 5v is less than negative 25. Divide by 5. V is less than negative 5. And I have a compound inequality here. I've got 2 inequalities, right? Coming from one equation, I've got a compound inequality. So the question is this an and or an or? It is an or. This is an or. So if it's greater than, it's an or. So I have 1, everything greater than 1, negative 5, everything less than 5. When your original absolute value is greater than, it's an or. Which means what's going on with the other one? It's an and. When it's less than, it's and. So I do the same setup. I split it into 2 problems. 3m minus 4 is less than or equal to 8. 3m minus 4 is greater than or equal to negative 8. Flip the inequality, change the sign. And then solve. Add 4. 3m is less than or equal to 12. Divide by 3. M is less than or equal to 4. Add 4. 3m is greater than or equal to negative 4. Divide by 3. M is greater than or equal to negative 4 thirds. Okay. So it's an and. So I graph it. I have 4, negative 4 thirds. It's or equal to, so I have 2 filled in dots and everything in between. And if you stop and think about it, it kind of makes sense. Whatever's in there, the absolute value has to be less than 8, some number less than 8. Well, I can't go on forever because eventually, if I take the absolute value of a number that's big enough, let's say I end up getting negative 100 in here. Well, negative 100 is less than 8, but the absolute value of negative 100 is not less than 8. So I have limits on that one going either way. If you are not sure if you got it right, there's an easy thing to do. Pick a point and test it. Pick a point in here between the unused space, between 1 and negative 5. What's the easiest point to test between 1 and negative 5? Come on, there's one that's so much easier than everything else. 0. 0 is between these. If I take 0 and put it in here and it doesn't work, 0 is not part of my graphical answer. If I put 0 in here and it doesn't work, I've got it graphed correctly. 0 times 5, 0 plus 10, absolute value of 10 is not larger than 15. 0 doesn't work here, 0 doesn't work there, they match. Okay. Same thing on this one. I pick a point, either one that doesn't work, or in this case it's easier, pick a point that does work. In this case, 0. 0 times 3 is 0, minus 4 is negative 4, absolute value is 4. 4 is less than 8. 0 works here, 0 works there. My graph in my original problem do match. I'm good. Okay, easy way to check yourself, make sure you got it right. I don't require that you check your work, but when you're doing a test, it might not be a bad idea to check your work. Make sure you got the right answer before you turn your test in. You know? Your turn, do those two. Okay, so first thing I need to do is separate into 2. 2n plus 4 is greater than or equal to 6. 2n plus 4 is less than or equal to negative 6. Subtract 4. 2n is greater than or equal to 2. Divide by 2. N is greater than or equal to 1. Subtract 4. 2n is less than or equal to negative 10. Divide by 2. N is less than or equal to negative 5. The original problem was a greater than, so this is an or problem. 1, negative 5. That's my solution. Okay. Same setup, same start. 2b minus 1 is less than 5. 2b minus 1 is greater than negative 5. Add 1, add 1. 2b is less than 6. Divide by 2, b is less than 3. Add 1, add 1. 2b is greater than negative 4. Divide by 2, b is greater than negative 2. Negative 2. 3. This one's an and. Open circles on this one. Everywhere in between. Questions on it? Yes?
I still don't understand the difference.
Okay. If it's an and, it has to be true for both of them. So on this one here, whatever b is, b has to be less than 3 and bigger than negative 2. I cannot have a number that is not less than 3 and bigger than 2 at the same time. Just because it's less than 3 doesn't mean it will work. Because I have numbers way over here that are less than 3 that will not work because they're bigger than -2. Same thing the other way around. And has to be true for both of them. Okay. If it's an or, as long as it works for here or works for here, I'm good. Doesn't have to work for both, just one of them. Okay? So, generalization for absolute value solutions. For the equations, if they're equal, split into 2 equations, one equal to the same, one equal to the opposites. Inequalities, greater than or equal to, oh, this one, there we go. Greater than or equal to, split into 2 inequalities, switching the inequality when changing the sign. This is an or inequality. Whether it's an and or an or is probably the most important part of the absolute value ones, that and switching it. You got to remember to switch the inequality when you change the sign, and remembering which one's which. But realistically, for an or an and, if you graph the answer, it kind of makes sense. The ands will overlap, the ors will not. So if you graph the answer and you don't have an overlap, you know that's an or. You graph the answers and you have an overlap, you only want to include the overlap, and that'll be an and. That'll kind of give you a hint. And then for less than, split them into 2, switching the inequality when changing the sign. These are ands. If it's less than, it's an and. Okay?